Good day, everyone. Today we are modeling exponentials. Our objective is to model exponentials in situations. For us to do this, we have to create equations for them, given word situations, solve for x, plug in values, not really, and use decimals. Those will come in handy later on, so yeah, those are true actually. We will be plugging in values and we will be using decimals. All right, announcements. All right, next week is your monthly test. Yeah, please do the homework. It's a lot thrown at y'all, but I need for y'all to go ahead and get all that done. All right, pay close attention to your Google Classroom. It has a lot of important information. All right, our agenda. We're going to review created models from upper elementary up to high school, Algebra 1, and then we're going to review exponential functions, and then we're going to get into those equations. All right, the essential question for this lesson is how are we satisfying the precise definition of mathematics using exponentials? All right, let's get into it. So remember, mathematics is the techniques to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Alright, here's a vocabulary word for you to try modeling. In mathematics, a model is an equation that is based on reality. And again, you've been doing this since your upper elementary days. So here's a situation. Let's talk about potatoes. So let's create a model based on the situation right here. We got potatoes that cost 54 cents each. So when we create our model, it's going to be y equals 54 cent x because you don't know how many potatoes you can buy. You can buy 3, 5, whatever. Now, bring this up to algebra 2. This is known as a linear function. A linear function. All right? Going back to your knowledge of your parent functions. Although this is a simplistic fifth grade situation, believe it or not, you've been dealing with linear functions since you was in elementary. And this is one of the parent functions that we have talked about. Linear. I just want to make sure that you guys know it. Linear. Again, you should know the name, you should know the function, and you should know what the graph looks like. Moving on. All right. So let's go model some more. So you got this situation. The difference of y and 14 is 18. If I was actually to create a model, which again is a equation, that is for reality, you're going to get y minus 14 equals 18. That's the model. If you notice, I did not solve any equations. All I did was to set them up. All right. So now we're going to get to seventh grade. The previous problem was sixth grade. The reason why this is a seventh grade problem, believe it or not, I taught seventh grade. So you are given a situation that looks like this. The height in feet of a tree after x years is 1.5x plus 15, and after unknown years, the tree is 24 feet tall. We have to create a model that is best represents the situation. Well, we got most of the model. The only thing we're missing is what it should equal to. And when we look at this, it's just 24. Now, if I ask you to solve this, you know to subtract 15 from both sides, divide everything by 1.5, and you're going to get 6. And you know that it would take you 6 years for the tree to grow 24 feet tall because that was the question that was being asked, and we answer it. All right. And again, that's 7th grade in the school. All right. Now, all the time when y'all say, "Oh, in 7th grade I was uh, dealing with COVID." Okay, cool, but that was a situation that was going on 20 in during the COVID situation for us people who were trying to buy a PlayStation 5. So here's this situation, and then let's create a model off from it. Now this is your 8th grade situation. So James must pay $600 with a 10% interest per month to pay off his PlayStation 5 of layaway. He paid off the PlayStation in 13 months. How much interest and how much did he pay when he paid finally for the PlayStation 5? Well, if you look at the situation, it looks like he's multiplying everything together. And when he does that, it's just going to be 600 times the 1 plus the 10%. And remember, to get a percent into a decimal, all you got to do is take the percent, 10, and divide by 100. And when you do that, you're going to get 10.10 or zero point 0.1, which is the same thing. All right. These are equivalent to each other. So that's cool. So let's move on. All right. So we multiply together. You realize he paid in total 1,380. That's how much he paid for $1,380. But when we subtract it, he paid $780 in interest. And this happened all over. PlayStations was crazy expensive because you had scalpers, people who were trying to, scam. And you even had them in stores too. All right, last. And now you're in your Algebra 1 situation. You know, let's talk about a person named Kiki. And this is a made up situation, but you know, today they were selling po' boys based on, and it works the same way. So Kiki's selling hot plates for $20. She spent $3,000 for the products to make the food. This model as a profit of y equals $20 x minus 3,000, while y is the profit and x is the number of customers. If Kiki had 1,000 customers, how much money did Kiki make selling hot plates? So it tells you the customers, and x is the number of customers. So you multiply that subtracted by 3,000, you get the profit. So you guys, again, this is still dealing with linear equations. So your y is your profit. So this is your slope-intercept form, right? This is modeled in real life dealing with profits. I mean, I just gave you a fine example. And now you guys are like, I ain't gonna use this in Algebra 2 at all. Believe it or not, this is Algebra 2. Because it's a linear function. And that's part of the parent functions we've been talking about. Alright? So again, modeling. Alright, now let's go ahead and get into it deeper. modeling exponentials. So you guys, you see Capital One, you see Chase Bank, you see a bunch of money. So believe it or not, we're gonna be dealing with some money issues today, y'all, because money talks and nonsense walk away. So money talks, y'all. And this what I'm showing you is something that you're going to be using that every adult use in everyday life. All right. So this is not me making it up. This is not me making excuses. And one other thing that you guys need to remember, people who got a mathematical skill are the ones who are actually running this planet. I know that's hard to believe, but they are running the show here. People with mathematical know-how. You know, our principal, believe it or not, she does have a particular mathematical set. She does. So just want y'all to understand, the importance of mathematics. And I'm not saying this just to be as a mathematician, but you know, you could research this. You find out that people with mathematical backgrounds make the most money. You could be a football player all you want, but if you don't know how to deal with your money, guess what? You ain't gonna make it nowhere. And this is not about counting your money. You can count your money all day, every day, but count doesn't really do anything. Okay? Mm. So let's move on. So exponentials deals with growth. Money grows, population, and health. Things are dealing with the rapid growth, decay, so, dealing with science and rapid decay. So like population decrease and all of that. All right. So that's deal with compound interest part one. So this is what I want you guys to understand. You guys gonna be opening up accounts real soon. You will, you know. And we're not talking about checking account, savings account. All right. And we're gonna talk all about that. But right now, let's talk about a particular problem about Baruch. So Baruch has $7 in the account that earns 10% interest compounded annually. To the nearest cent, how much interest will she earn in 2 years? Use the formula B equals P times 1 plus R to the power of T, where B is your balance, your final amount, and P is your principal, your starting amount, and R is your interest rate expressed as a decimal, and T is your time in years. So we try and figure this all out. All right, so let's do it. So all I did so far was to put everything, all the numbers, in that proper place. Because $7 is where she started off at. She started off at $7. And then we used the formula, the growth formula, 1 plus the rate to the power of t, to use everything else. So 10%, we write it as a decimal because you do that in the formula. Again, for those who don't know how to get a percent as a decimal, 10 divided by 100 gives you 0.10. I know I talked about this already, but in case for those who forgot how to do all of that. So that 0.10, that's the decimal of 10%. And then the number of years, which is 2, which replaces the t. So when we use decimals or a calculator to calculate this in, you get $8.47. So that means after 2 years, Brooke will earn $8.47 in interest. I mean, 42. I mean, $8.42 in 2 years. So let me erase this. Now, she started off at $7 and she went to $8.47. So the question is, how much interest did she earn? She went from $7 to $8.47. So when she did that, she went $1.47. And that's the interest she earned. All right. So y'all, that don't sound much, right? Well, it does, but this formula is applied to everything. When you guys dealing with buying a car and you trying to figure about a car note's calculated on this. It is, you know, when you trying to buy a house, that compound interest, it falls to these kind of models. And this is your exponential model. So guess what? I know you say you ain't gonna never use exponentials. Guess what? But you are using them right now. And when you become grown and you're gonna be using exponentials. But just as a reminder, depending on what you want to do in life, you're gonna either see it very little like this, or you're gonna see more exponentials. All right. So I want you guys to understand. Depending on which profession you get into, it just depends how much math and stuff you're going to use. All right. But everybody is going to be using this exponential stuff. All right. Now, the cake situation, you're like, well, that ain't much. But when you put money in a savings account, you will watch it grow. Savings account. All right, so let's talk about case two right quick. Now this is what happens when you open a bank account, and when you open a savings account, this what happens to your money. Billy puts $400 in an account to use for school expenses. The account earns 50% interest, compounded annually. How much will be in the account after 10 years? Now, you gotta use this formula: A equals P times 1 plus R divided by N to the power of N times T, where A is the balance of the final amount, P is the principal starting amount, and R is the interest rate expressed as a decimal. N is the number of times per year that this interest is compounded. You gotta figure that all out. All right. So if I'm saying the word annually, what does that mean to you? Annually means once per year. Okay? If I was to say quarterly, quarterly, I misspelled that, but yeah, I get the gist. Quarterly means 4 times a year. And monthly means 12. So pay close attention to all of that, okay? So let's get back to this. Again, this is a real situation that you guys gonna also be doing too when you open your savings account. You can talk to your moms about it, talk to your dads about it. Everybody deals with the savings account. So now let's answer this question. So the principal amount is your 400 because that's how much you start off with. Your rate is 15%. Again, 15 divided by 100 gives you 0.15. N is once per year because it's annually. That means it's going to happen once. And then the T is your time, and that's 10 years. All right, so let's move on. It's still the same problem, but we're setting the pieces up. So when we set this up, this is your P, this is your rate, this is the number of times that it's compounded, which is once a year, and that 10 is the number of years, times how many times it get compounded a year, which is just once because it's annually. Right. You put this in decimals, guess what you get? You're going to get this big number, but because you're dealing with money, you got to round it to the nearest cent. So when you round it to that, because you look at your 3 as your place value, it's less than 5, so it's going to be 22 cents. So to the nearest cents, Billy will have this amount of money in his account after 10 years. All right, so periodic compound interest. You don't have to pay attention to all this stuff, but again, when you open your first savings account, you know, when you put money in the bank, you will watch it grow. And we would do a little activity on this so you could, further understand how compound interest grows. But this is called your periodic compound interest because of your N. Your N, it could be, it tells you how many times per year your interest grows. Maybe your interest will go semi-annually. Semi means, not a whole year. So we usually say twice a year. All right. Quarterly is 4, monthly is 12. But when you open your savings account, your interest will grow monthly. All right. So case 3, you're dealing with no formula, but you're dealing with the human population. So a town population currently has 20,000. If the population double every 34 years, what is the population be 68 years from now? To do a situation like this, you have to use division. 68 divided by 34. When you do that, you get 2. And that's to determine the doubling amount. All right? And when you do that, all you gotta do is multiply times 2 because it says double, because it says double, to the power of 2 because that's how many times it would double between when you divide 68 to 34. And you get 80,000. Pretty easy formula. All right, we are at our last case. So sometimes you're going to be given this situation. You scan that photo into a computer at 4 times your original size. You continue to increase its size repeatedly by 100% using the computer. The next size of the photo in the comparison of the original size of the x enlargement in the computer represented by this equation y equals 2x plus 2. How many times was the photo being enlarged on the computer so the new photo is 32 times the original size? All right. We know how to solve these equations. We know what's given to us. We know that y was given to us. I'm gonna quickly go through this, but you need to figure out how we got to these steps. So I showed up my work. All right. You gotta figure out how I got to that. So, how do we satisfy the essential question? We use techniques such as solving exponential equations by keeping the bases the same and prime factorization to model exponential functions such as fineness, photos, and population. We plugged in, we did everything else. All right, y'all, that is it. You got any further questions, please see me.